Storage in the database has an interesting history. Customers have traditionally used one tier of storage for their databases, and it's their most valuable data that they're putting in the Oracle database, so they of course spend the most money on storage for the database, and what people typically call tier 1 storage. And so most customer databases even today are still primarily on one tier of storage, usually the most expensive tier, the most high performance tier. What's been happening is those databases have been growing faster and faster, essentially growing at an exponential rate. And it's becoming less possible, less affordable to just keep on buying more tier 1 storage when the amount of data you have to store in your database is growing so fast. And so the challenge is, okay, how do I figure out what parts of my database should stay on my tier 1 storage, what parts I can keep online but move to some slower, cheaper, denser tier of storage where at least it's online, but the performance isn't as good, but it's still available when I need it. In past database releases, we've implemented a number of different features to help customers manage storage. Partitioning lets you transparently segment the data in a table, usually your larger tables, so that each partition can be managed independent of the others. So you can put each partition on a different tier of storage if you want to. You can actually compress each partition separately with different compression algorithms, depending upon the workloads. Another important feature is ASM, or automatic storage management, which makes it easier to optimize how data is laid out on a set of disks, so that you get all the performance of striping data across all your disks, and all the availability characteristics of using mirroring to ensure that a single disk failure doesn't result in any loss of data. There's a number of compression features in the Oracle database that we've added over the years. The advanced compression option, which actually has about 5 different features in it to help you compress table data and unstructured data and RMAN backups and data pump exports and data guard traffic. And also in 11G Release 2, we added hybrid columnar compression. Originally, it was part of Exadata only. More recently, we extended support for hybrid columnar to ZFS storage appliance and Pillar Axiom storage. And as the name implies, hybrid columnar uses a column-based format for storing data, which delivers 2 things that is much harder to do with a row-based format. Column-based format gives you the ability to get higher compression ratios because you're storing all the data for a column together. So all the data is by definition of the same data type and often very similar values. So it's easy to get higher compression ratios. And columnar format helps greatly improve the performance of analytic type queries, business intelligence type queries that scan lots of data. Columnar format helps with performance of those types of queries. You can use partitioning and compression, both advanced compression and hybrid columnar, to do a lot of what you want to do. You want to do storage tiering, you want to compress data more aggressively based upon how cold or hot it is. But you have to figure out manually when it's okay to move a given segment of data to a slower, cheaper, denser tier of storage, or to move it to a more aggressively compressed format. It's up to the DBA or the system administrator to figure out when it's okay to move data. And so it is still mostly a manual process with 11G Release 2 even. With Oracle Database 12c, we've added capabilities that make it easy to automate the movement and compression of data. And those 2 features are the heat map and automatic data optimization. And the heat map, as its name implies, the database keeps track of when data is accessed, even to the level of detail of keeping track of modifications, insert, update, delete, separate from queries, from full table scans, and even index lookups. So we distinguish those 3 types of access, and it's tracked even at the block level in the case of modifications. But we track it at the block level and at the table level and at the partition level, all automatically, so that the heat map gives you deep insight into exactly what data is being accessed and what data is not being accessed. How cold is the data? How cold is a partition? How cold is a block? And that's great. So you've got this heat map. Automatic data optimization is a simple declarative policy-based way for you to tell the database what to do with data based upon how cold it is or how hot it is. And so all you really do with ADO is to define these policies on your tables, and then the database will automatically move data around as it qualifies based on your policies. The daily work of a DBA and a storage administrator, system administrator, we think is going to change quite a bit with the use of the heat map and automatic data optimization, because before the heat map and automatic data optimization, they had to write scripts and jobs and constantly be updating those scripts and monitoring the jobs, make sure they're running correctly, to move data around, to implement tiered storage and compression tiering. With automatic data optimization, it's a lot easier. They simply create these declarative policies, and then they can monitor the database automatically moving the data around. So there's just a lot less work for them to do to implement the storage plans, essentially the information lifecycle management policies they want to implement. And this lets them save a bunch of space and improve performance. Since we've integrated it up and down the stack in the Oracle database, we actually see significant improvements in performance, not a slowdown in performance, but a speed up. And so tie it all together, you save space and improve performance, and in 12c you do it all automatically. So the DBA in 12c will now be able to, with some simple policies, implement storage tiering and compression tiering that will save his company a lot of money on storage, and at the same time actually improve performance. We don't see anything from the database competitors that do anything like this. Some of the storage vendors have implemented some automated tiering, automated storage tiering capabilities. The problem with those capabilities, of course, is that they're not database aware. From the perspective of what we see competitors, we haven't seen anything like the heat map from anybody in the database world. And even the storage tiering from the storage array vendors, it's blind as to what the database is doing.